One of the biggest obstacles to lunar development is lunar landing frequency, how often you can land a payload on the moon. We discussed these problems in detail in a previous video, but the main idea is that because of launch infrastructure and logistics, it's likely that even after decades of investment, efficiency gains, infrastructure, workforce, and supply chain buildouts, we'll still only be able to land on the moon a maximum of 60 times a year. If that payload is 200 tons, it would mean our lunar economy could only support 1,500 people. I know it's crazy saying 1,500 people on the moon isn't enough, at a time when we haven't had a single person on the moon in over half a century, but when you envision the future of humanity, how many people do you imagine living and working off-world? 100? 1,000? 10,000? 10 million? So we have a logistics problem. Even if we can make tons of stuff on the moon, we're still always going to need imports from Earth. We need to move a lot more mass between the Earth and the moon, but unfortunately the go-to answer of simply increasing the size of the rocket would introduce a ton of complications for only marginal gain. It's possible to do this for sure, but it doesn't really solve the core issue. The real issue impacting lunar landing frequency is not the size of the rocket, but rather the unavoidable need for orbital refueling of super heavy lift launch vehicles if they're going to make it to the moon. But what if they don't? What if, instead of going all the way to the moon, they could rendezvous with another spacecraft in low Earth orbit, which could take on their payload and fly it all the way back to the moon? Well, then the Starship-like rocket wouldn't need to be refueled. It could just serve as a ground to low Earth orbit shuttle, and the secondary spacecraft would never need to enter into Earth's atmosphere, which means it won't need to be aerodynamic, and if it's just taking on cargo, it can be fully automated, which means no humans, which means no pressurized interior hull. It can be made very simply, just a platform essentially, which means we could make the entire thing out of steel, made from lunar regolith using chromium anode electrolysis reactors, which means we can scale this thing up to be extremely large, and it could take on several Starship-sized payloads in a single trip. And what if we could launch these from the moon into orbit using a mass driver operating on technology similar to this new self-contained maglev train able to operate on traditional rail lines, meaning the lunar mass driver would not need to be some infrastructure mega project, but rather just simple rails, and the freighter itself would only need to expend energy for small maneuvers and the lunar descent burn. And what if this process repeated continuously, allowing us to basically have constant imports to the moon? Well then, I suppose we'd solve our supply problem while also kickstarting a domestic lunar shipbuilding industry and laying the foundations for a larger expansion into cis-lunar space and the rest of the solar system. And what if we make something like the shipping container of space? On Earth, shipping containers have revolutionized supply chains as they allow loads to be easily transferred from factory to truck to ship in a standardized fashion. So what if we could make something like that, but large enough to take on the 1,000 cubic meter volume of a super heavy payload? Maybe we could make it a hexagonal design, which might optimize the trade-off between design simplicity and usable volume. And what if, to facilitate this payload transfer between craft, we could build some sort of mechanized scaffolding, essentially an orbital port, just a simple matrix which could move payloads from the Earth ship to the lunar ship. And maybe we can divide this port into 3 sections, one side for empty containers, the other for full containers, and a loading area. And perhaps we can design it so that once a ship arrives at the orbital port, it won't need to dock. It can simply maneuver into approximate range, open its fairing doors, and the payload could then be captured by the port itself, after which it would be transferred into a waiting container. That container would then be moved into the full area where an incoming freighter would pick it up after dropping off its load of empty containers on the empty side. Then that freighter would return to the moon fully loaded with supplies for a growing and thriving lunar economy. Now you'd think it would be as easy as just landing on the moon, unloading, then launching back and repeating the process. But here our real troubles begin, for in those details there be devils. You don't want to land the freighter too close to the lunar base for safety reasons, but you do want to unload your cargo close to the base for efficiency reasons. You also need to figure out a way to refuel the vehicle, which means you need a fuel depot, but you don't want that to be anywhere near your landing spot. And also you'll want to load your freighter with empty containers to return them to the port for that closed loop container trade. And perhaps most tricky is figuring out how to move a giant freighter onto or into a mass driver. Do you use a bunch of gantry cranes for everything? Do you add wheels to the freighter, adding to its weight? Do you grab it with chopsticks? So there's a ton of technicalities for any would-be lunar developers to figure out, and I wish you all luck because there's no way in hell I'm going to do all that conceptual work myself. That would take weeks, and to be honest, it probably wouldn't even be worth it since modern YouTube is way more about upload frequency than anything else, so I definitely shouldn't waste my time making high-quality animations on, say, making the mass driver itself a landing pad and landing the freighter on it directly, and then using the driver to transport the freighter to the loading dock outside the lunar base, where it will unload, then be reloaded with empty containers before blasting off into the horizon to repeat the process again and again. Thank you to Leo, Ted Thayer, Adam Rodanis, Rick, Jonathan Crone, Mustafa Mond, Joshua Paletti, and Stephen Reed for supporting the channel.